Hi everyone, I'm Chua from CS and we are from Python groups that are taking the GEB2082 asset management in Malaysia. In this video, we will be covering about the decommissioning of asset, and the asset that we have chosen is the offshore oil and gas well. Before we proceed, we would like to take this opportunity to extend our gratitude to our two beloved lecturers who are Dr. Ainul and also Dr. Pao for the guidance throughout these semesters. For information, our group consists of 5 members, which including me, myself, Haarinesh, Nigel, Jeffery, and Suenisha. First, introduction. According to the data in the year of 2018, there are more than 3.2 million of abundant oil and gas wells emitted a total of 281 kilotons of methane in US. At the same time, in Canada, it is estimated that there are 313,000 abundant wells emitted 10.1 kilotons of methane in total. Due to the incomplete data, it is expected that the actual amount could be as much as 3 times higher. For information, the unplugged and improperly plugged oil and gas well can pose a variety of environmental and health hazards, and this including the first, contaminate the surface and groundwater, second, lead to the explosion risk, third, endanger human health due to the emission of air pollutant, and lastly, the emission of methane, greenhouse gases, and also ozone precursor. As mentioned previously, the asset that we have chosen is the offshore oil and gas well. So, what is it about? Basically, an oil well is a hole dug into the earth that serves the purpose of bringing oil or other hydrocarbons such as natural gas to the surface. Oil wells almost always produce some natural gas and frequently bring water up with the other petroleum products. For information, wells are created by drilling down into an oil or gas reserve that is then mounted with an extraction device such as a pump jack which allows the extraction from the reserve. Regarding the drilling cost, the daily rate depends on the rig type, distance from the shore, drilling depth, and also water depth. Hence, the offshore drilling can cost between $600,000 to $800,000 per day. Offshore well can further be subdivided into two, which are the first, well with subsea wellhead, and also second, well with dry wellhead. Basically, that's all from me, and now I will pass the floor to Jeff.
Thank you, Chua. Now we are going to talk about decommissioning of asset. First of all, what is decommissioning of asset? Asset decommissioning is the removal and proper disposal of an organization's fixed asset from its service and usage. This process is an important measure to ensure minimization of costs and higher quality products instead of relying on poor condition equipment. For this case, decommissioning of wells, or commonly known as well abandonment, is a process of plugging or sealing the oil and gas well safely and restoring it to its original state. In oil and gas industry, there are legal requirements under Petroleum Act of 1998 stating that when a fuel production cycle ended and all the usable fuel has been processed, the facilities must be demolished and the surrounding land has to return to its natural state. So why do we decommission offshore wells? Unplugged and abandoned wells can potentially jeopardize people's health due to the emission of air pollutants. Pollutants such as methane, butane, and benzene can be harmful if released to the surrounding and having the potential of causing fire and health hazard. Other than that, the fluid or oil leakage from the well can also cause environmental concern as it could seep into the nearest freshwater sources, which will impact the ecosystem of marine life. Moreover, offshore wells are also decommissioned as they are no longer useful for oil and gas production. According to Canada's oil and gas producers, the oil and gas well lifespan is only 20 to 30 years on average. After 30 years, the oil and gas wells are no longer economically active and stop producing oil and gases. Last but not least, decommissioning an aged oil well helps to reduce the cost of oil and gas production. This is because the production of an aged oil well is more costly compared to a new oil well since it requires dig deeper. To say the least, abandoned oil and gas wells need to be correctly managed and decommissioned to ensure the safety of the environment and society. That's all from me. Now I will pass to Nigel to continue the presentation.
Thank you, Jeff. Now let's move to the processes involved. The processes involved in well decommissioning is called well plugging and abandonment. It is a process where production wells that are no longer being used must be plugged and abandoned. This process begins with squeezing all perforations with cement and to avoid any leakage occurring during the well plugging. And then the tubing will be cut and removed at specific depth below the mud line to give space for cement plug. Once the tubing are removed, the wells are plugged by setting up mechanical or cement plugs in the wellbore at specific length and interval. This is to prevent oil and gas reservoir fluids flowing up the hole. This process usually takes between 7 to 10 days to complete, depending on the number of wells, issues related to the wells, and service providers. When all well bores are permanently plugged with sufficient seals, the well will be abandoned. It is important to note that well plugging and abandonment process returns nothing on investment for oil companies, so most wells are plugged at the lowest cost possible while obeying the minimum requirements set by the regulators. Now let's move on to the financial or business decision during decommissioning. Inflation. The rates for decommissioning vessels will increase to the Construction Price Index (CPI), and this will affect the cost of vessels for well plugging due to the increasing rates. So it is best to avoid commencing decommissioning during high inflation rates for lower decommissioning costs. Safety must be prioritized during well plugging to prevent injuries and death of workers. Equipment with safety hazard may also be damaged if continued to be used, which may impact the cost of maintenance. These incidents may delay the process, which could cost more. Technology plays a significant role in decommissioning as new technologies tend to be more efficient and economical in the long run. Outdated technologies may cost more and require more time to operate, which will drive the cost upward. Weather may impact the decommissioning process and indirectly impact the cost of decommissioning. Bad weather means plugging process must be halted to avoid unwanted incidents, which will drive the cost upward. Regulation plays a significant role in decommissioning. Some countries or regions impose different regulations for decommissioning, which may differ in requirements and degree of compliance and safety. Regulations will set a standard for operators to follow whenever cost cutting is needed to make sure it is within the minimum requirements. Resources availability is crucial during decommissioning as it may impact the decision on decommissioning techniques and equipment use. Thus, the resources availability in certain regions may impact the decision for decommissioning. Lastly, wellhead. Wellhead access is crucial in plugging process as it is a challenge that may significantly impact the cost. Wellheads without access fitting to all casing annulus sections will require the team to plug the casing one by one, and this will consume cost and time. Thus, it is crucial to inspect the wellheads to determine the plugging techniques and cost required. Now I will pass to Hari for regulations.
Thank you, Nigel. Now, let's take a look at legal and regulation involved. There are various laws and regulations at federal and state level that governs activities relating to overall decommissioning of oil and gas facilities in Malaysia. Some of the main regulations involved are as Environmental Quality Act 1974, which is to prevent and control pollution and to enhance the environmental quality in Malaysia. Second up is the Petroleum Development Act 1974 for exploration and exploitation of petroleum, whether onshore or offshore by a corporation. Next is the Exclusive Economic Zone Act 1984, known as EER, pertaining to the exclusive economic zone and certain aspects of the continental shelf of Malaysia, thus providing regulation of its activities. The fourth regulation is the United Nations Convention on the Law of Sea that governs all aspects of sea, including maritime boundary, delimitation, and many more. The final major act is the IMO, also claimed as International Maritime Organization Guideline and Standard, which says that disuse offshore should be removed when it is no longer serving its purpose. Now, let's take a look at the costs involved in decommissioning. We must take note that the cost of shutting down an offshore or gas well varies depending on their respective condition. In this case, we are taking Malaysia and United States as study material. According to the latest newsletter from Energy Voice dated 2021, by 2030, it is estimated average cost per field will be in the range of $150 million to $500 million for Malaysia. In contrast, in United States, the median cost of plugging and reclaiming is $76,000. Okay, now we take a look at the factor affecting cost and factor affecting disposal. So there are 5 factors affecting cost, which are type of wells, characteristic of the wells, surface features, bonding criteria or conditions, age, and location. Next, factor affecting disposal. We have 5 also, which are end of economic life, asset integrity, health, safety, security, and environment, depleting reserve or well performance, and finally, the facility is no longer required for development or operations. Thank you. Now, I will pass to Suenisha to explain about risk and how to mitigate.
Risk and how to mitigate. Firstly is the escalation of risk in human safety. The personnel who are handling the decommissioning process are exposed to the unplugged or improperly plugged oil and gas wells, can pose a variety of environmental and health hazards. To mitigate the risk, personnel should be well equipped throughout the process and wear a personal protective equipment, PPE such as the respiratory protection, to avoid inhaling toxic gases during the process. Next is the risk of potential leakage in plugged gases and fluids and abandoned wells. Choosing the best plugging materials to perform plugging is very crucial to ensure leakage of toxic gases and fluids. At the local level, degradation of the cement and steel that make up a wellbore can lead to the migration of gases or fluids that may contaminate the surface water and groundwater, and in some cases, accumulation of gases can lead to the explosion risk. Hence, plugging materials should be chosen accordingly, such as Portland cement and bentonite. Lastly, the poor waste management from the process. There will be quite a lot of waste. Thus, eliminating the possible waste, reduce and reuse the material and products that are reusable in their original forms. To encapsulate, the proper choice of plugging material is very vital in the whole process to prevent leakage and contaminations. Moreover, preparing a good emergency response plan are also vital to mitigate the risk. Last but not least, the average cost of decommissioning in Malaysia is significantly higher than the United States. The characteristic and the surface features, also the age of the wells, are affecting the cost of decommissioning. These are the list of our references that has been used throughout the making of our assignments. These are also the list of the references that has been used by our team. That is all from us on decommissioning of offshore oil and gas well. Thank you for listening.